Hey guys, Mr. Yisley here. So we're on to lesson number 6 in chapter F, all about fractions. So lesson number 6 is all about how to convert a fraction into a decimal. So really about a 4-step approach to this of what we need to do to make that happen. So first thing that we've got to do is we've got to put the numerator inside the house. So we're going to take the top number of the fraction and we're going to put that inside the house. The second thing we're going to do is we're going to put the denominator to the left of the house. So the denominator is going to be the left house. So we're simply dividing the denominator into the numerator is what we're saying. Third thing we do is we actually divide it. So now we're going to do our division and see where that gets us. Once we've done our division, fourth thing we're going to do is we're going to keep, adding decimal places. So we're going to keep adding decimal places. Those are usually zeros, as needed. So as needed, or until there is no remainder. So once we figure out that, hey, we've gotten it evenly in, then we're done, right? If we have to keep bringing zeros down, those imaginary zeros we've talked about previously, then we keep doing that. And then last thing we want to do is we're going to round to any place value that they indicate to us in the assignment, right? Now on the examples, I didn't indicate a place value, but we'll talk about that here in a second, what we want to do. All right, so we've got 3 examples here. Example A is 2/3 or 2/3. So first step is we need to put the numerator inside of the house. So I've got my numerator, the 2, is going to go inside of the house. Then I need to put the denominator to the left of the house, so my 3 is going to go to the left of the house. All right, and that's completely fine. All right, third thing we need to do is we need to actually do the division. Well, you're probably looking at this going, 3 does not go into 2. Well, here's where we've got to add that decimal point and the imaginary 0. So our decimal point, it goes up, it's going to end up right there. So 3 did not go into 2, so 0 times, but 3 does go into 20. Right? 3 does go into 20, because remember when we divide, we pretend like the decimal's not there. 3 goes into 20 6 times. 6 times 3 is 18, and 20 minus 18 is 2. All right, so I still have a remainder, so again, I've got to bring down another imaginary 0. So I'm going to add it right there, and I'm going to continue on my house, make it a little bigger. When I bring down that 0, I end up with 20. Well, 3 again goes into 20. 6 times 3 is 18. So subtract that, you end up with 2. Still have a remainder 2. So again, I've got a add a 0 and bring it down. So I've got 0. 3 goes into 20. Again, 6 times 3 is 18. And you may notice at this juncture that the exact same thing is happening over and over and over. Right? And this is known as a repeating decimal, right? And when you end up with repeating decimals, all we have to do, is we need to have the first 3 numbers, so to the thousandths, right? And we write that number 0.666 here, right? And then we put this line over the top of it, and that just means it's going to repeat that process over and over and over and over. All right, so there's just going to be 6s going on forever. It's never going to end, and that's what that means. So our final answer here is 0.666 repeating. So when you end up with those repeating decimals, we want to make sure that we recognize, hey, this is the pattern that's happening. Sometimes it's not going to be the same number repeating over and over. Sometimes it'll be a combination of numbers. Could be like 1, 2, 3 keeps happening, and then it happens again, 1, 2, 3. And so we just put the 3 numbers that are a part of the combination and a line over the top. All right, and again, that's called a repeating decimal. So let's move on to example B. We've got 19/8 or 19/8. Right? So first things first, let's create our house. So I got my house out here to the side. Put the numerator inside the house. So 19, that's going to go inside the house. Denominator to the left of the house, so that's outside the house. Third step, we need to divide it. Well, 8 doesn't go into 1, but 8 does go into 19 2 times. Well, 2 times 8 is 16, so 19 minus 6 is 3. So I've got a remainder of 3, which means now I've got to add that decimal in. So that decimal is going to go up there. All right, add one of those invisible zeros and bring it down. So I've got 8 into 30 now, right? Well, 8 into 30, or 30 divided by 8, 8 goes in 3 times, right? 3 times 8 is 24. So subtract that, we get 6. Again, got to add another one of those zeros, extend my house, bring it down. And I've got 60 here. All right, 8 goes into 60, goes in how many times? That would be 7 times. All right, haven't found a repeating yet, so we got to keep going. 8 times 7 is 56. Subtract that, we end with the remainder of 4. Again, add another 0, bring it down. So 40, does 8 go into 40? Yes, it does, 5 times, right? And 8 times 5 is 40. So we brought it down, and now we finally got to a remainder of 0. So that means that our answer is that full number, which is 2.375. So see, sometimes we get repeating decimals like on example A. Sometimes there is an actual ending point to that decimal place, and we never had a pattern. We just eventually hit a decimal place that it ended at. And so that is the final answer. All right, so now I'd encourage you to try example C on your own, and then check your work with mine. All right, so first one, put the numerator inside the house. So here's my house, numerator goes inside, right? Denominator goes on the outside. Step 2, step 3, let's divide it. Well, 4 doesn't go into 3, so add my decimal place, then a 0, bring that decimal place up. Well, 4 didn't go into 3, so that's a 0. All right, but 4 does go into 30. It goes 7 times, right? Well, 4 times 7 is 28. 30 minus 28 is 2. Add another 0, bring it down. So I've got 20 now. Does 4 go into 20? Yes, it does. 5 times. And 4 times 5 is 20. Subtract. I'm down to a remainder of 0, so I am done with that problem. So my final answer is 0.75, or I'm okay with if you just put 0.75. Either one is an acceptable answer. But this is the work we have to show, right, in order to show how we arrived at our decimal. As we get along farther in the chapters, right, you'll start seeing this and recognizing it right away, and we'll be able to just say, hey, 3/4 is 0.75, 2/3 is 0.66, repeating. But right now, we need to be able to show the work to show how we got to our decimals. All right, well, that should be enough to show you what you need to continue on in the playlist. If you have any additional questions, please let me know.